Pluto is a far-off and subtle, more unassuming planet that was once a piece of our close by planetary framework, anyway progressing upsetting declarations by driving astrophysicists. Neil deGrasse Tyson and Mayo Kaku have brought Pluto back into the spotlight. They recommended that this cold world is on a potential impact course with Neptune, yet how is it that this could truly work? Furthermore, what may be the aftereffects of such an colossal occasion? Are we seeing a befuddling gigantic whimsicalness, or is there another thing to this approaching ceaseless misfortune go along with us as we look at the likely consequences of a Pluto-Neptune influence? Pluto, a previous planet that was renamed as a Bantam planet, stays a subject of interest and concentrate in the tremendous universe as shown by late suppositions from driving experts. Pluto's circle is unsafely near Neptune's, and astrophysicists Neil deGrasse Tyson and Mayo Kaku are both raising the alert about an expected perilous mishap between these two planets, which could imply a gigantic danger to Earth. Yet, how is such an occasion even conceivable? Pluto's outing around the Sun is not at all like that of some other planet in our Sun-based framework. It requires a stunning 248 years to finish a solitary circle, and since its disclosure in 1930, it hasn't even completed one full insurgency in any event. The interest doesn't stop there. Pluto's circle is set apart by its especially circular shape, meandering generally from the nearly circular circles of the major planets. What makes Pluto's circle a lot more astounding is its tendency, which is 17 degrees to the ecliptic plane. The way Pluto follows its way is fundamentally more unpredictable contrasted with different planets. This propensity and capriciousness add layers of intricacy to its orbital plan. Quite possibly of the most charming pieces of Pluto's circle is its convergence with Neptune's for around 20 years in each circle. Pluto really moves nearer to the Sun than Neptune, challenging what we could anticipate from their positions in the planetary framework. This prompts the standard inquiry: why hasn't Pluto slammed into Neptune? The response lies in the gravitational impacts of different planets. The assessment of Pluto's circle started not long after its revelation. At first, space experts endeavored to sort out its exceptional way, not at all like other planets whose circles lie genuinely near the ecliptic plane. Pluto's circle stands out with its profound tendency and flighty shape. The secret developed with the acknowledgement that Pluto's circle does, to be sure, across Neptune's. The steadiness of Pluto's circle, in spite of these complexities, is proof of the intricacies of heavenly mechanics. The three-body issue in space includes deciding how three items in space like Pluto, Neptune, and the Sun move and impact each other with their gravity. It's like attempting to anticipate where they will go in view of where they began and how they pull on each other. For Pluto's situation, this issue shows how its circle, Neptune's circle, and the Sun's gravity all work together in a complicated manner. The terms non-simultaneous libration, orbital precession, and VSK wobbling are vital to this riddle, is made sense of by astrophysicists. What keeps all planets in their circles is non-simultaneous libration. Concerning Pluto and Neptune, this term basically implies that when Pluto crosses Neptune's circle, it is situated something like 90 degrees away from Neptune. This spatial division is basic in keeping their circles from meeting. Orbital precession, then again, alludes to the upward development of a body in its circle. For Pluto, this implies that when it comes nearest to Neptune or some other Goliath planet, it is situated far over their orbital plane, adding an additional layer of security from potential influences. One more key figure this circumstance is the VSK wobbling, named after three analysts Zell, and Kai-Hu, concentrated on how articles move in space. It includes how three space objects like Pluto-Neptune and the Sun pull on each other with their gravity. This pulling impacts how they move for Pluto's situation. The VZK wobbling assists us with figuring out why its circle near the Sun is so strange, notwithstanding Pluto's circle seeming tumultuous. This wobbling aids keep it moving. Easily overstretched periods. The VZK wobbling shows that despite the fact that things in space appear to be wild and erratic, examples and rules keep up with some control. These powers assist with keeping Pluto's circle stable, guaranteeing that it doesn't impact with Neptune or float off kilter. This three-body issue is vital in understanding how these circles change. Because of the manner in which space objects pull on each other, concentrating on this assists us with learning more about Pluto, our nearby planet group, and, indeed, even far-off universes and their stars. Mathematical reenactments in the last part of the 1980s uncovered that regardless of the settling properties, Pluto's circle is, in fact, unpredictable with minor deviations in starting conditions prompting tremendous contrasts over hundreds of years. Anyway, these idiosyncrasies of Pluto's circle have been found to keep up with dependability over incredibly lengthy timespan scales. Checking the disturbance from later programmed assessments has assisted us with understanding how the monster planets like Neptune, Jupiter, and Saturn influence Pluto's circle around the Sun. Neptune has an exceptional relationship with Pluto, where for each two circles Pluto finishes around the Sun, Neptune finishes 3. This relationship helps keep Pluto's circle stable. Anyway, Neptune isn't the, as it were, one at work. Jupiter's gravity likewise plays a monster job in settling Pluto's circle. Saturn likewise contributes. These concentrates on show that Jupiter's gigantic gravity is sufficiently able to guarantee Pluto stays on a consistent way for quite a while, possibly in any event for a long period of time. So perhaps Neptune, Jupiter, and Saturn are coordinating to ensure Pluto proceeds to move securely through space without running into inconvenience. These peculiarities are critical to keeping everything set up and protected in space. Without these components, the sunlight-based framework, as far as we might be concerned, would be a much more brutal. Spot bodies like Pluto could crash into others or be catapulted from their steady circles, setting off a chain response with other divine bodies for Pluto, particularly with conversations about it possibly slamming into Neptune later on. Understanding its circle is critical. This gives a more clear image of the dynamic nature of the closed by planetary framework. The instance of Pluto shows how even the most apparently unsound circles can reach a condition of equilibrium through the complex collaboration of gravitational powers and orbital mechanics. It additionally highlights the significance of consistent perception. Also, investigation of these peculiarities to better figure out our position in the universe. Investigating the profundities of room frequently drives us to go up against the peculiar nature of heavenly bodies, and Pluto's circle is an optimal illustration of this abnormality. The idea of orbital turmoil, which alludes to the delicate reliance of a heavenly body's circle on its underlying conditions, is plainly shown in Pluto's case. This implies that even slight changes in the Bantam planet situation, or then again speed, can decisively change its long-haul circle. Utilizing computerized reenactments has been massively useful for researchers in sorting out how Pluto moves in space. These recreations use complex math to show how Pluto, furthermore, other space objects like Neptune pull on one another by tweaking little subtleties in the reenactment space. Scientists can perceive how even minute changes can have a gigantic effect in where Pluto winds up in the last part of the 1980s. These reenactments showed something Intriguing about Pluto's circle, in spite of having highlights like non-concurrent, libration, and orbital precession to keep it stable, its circle can in any case be conflicting and uncommon in the event that you start with simply a little distinction in where Pluto is, or the way that quick it's moving. Its circle could wind up looking totally different after only a couple of years yet. In spite of this confusion, Pluto's circle remains stable throughout huge timescales like billions of years. This actually intends that Pluto's excursion around the Sun has a sort of request to it, despite the fact that it shows up wild at first, anticipating divine developments, particularly when they include sporadic circles, as is Pluto's. A monstrous test. The innate capriciousness of these frameworks implies that drawn-out estimate tests are frequently loaded up with vulnerabilities, while mathematical models give brilliant apparatuses for understanding and anticipating the future developments of heavenly bodies. They additionally feature the restrictions of our prescient capacities. These models intensely rely upon the precision of beginning circumstances, and any little misstep, or on the other hand mutilation, can prompt incomprehensibly various results, making exact forecasts an overwhelming errand. Other than the tumultuous idea of planetary circles, Pluto helps us to remember the ever-changing and dynamic nature of the universe. While we've taken colossal steps in understanding space, Pluto's case helps us to remember how much our insight into the universe still stays restricted. Getting a handle on the gravitational impacts of the monster planets on Pluto's circle gives important experiences into the more extensive elements of the nearby planet group. It shows how the presence and position of each planet can fundamentally influence the dependability and course of different bodies inside the framework. So why are driving astrophysicists as of late raising worries about a possible crash among Pluto and Neptune, notwithstanding all these perplexing powers attempting to forestall such an occasion from happening? Neil deGrasse Tyson, an unmistakable astrophysicist, furthermore a significant figure in progressing cosmology, offers a novel point of view on the secrets of our nearby planet group, particularly the fascinating instance of Pluto. Tyson, known for his part in renaming Pluto from a planet to a bantam planet, offers quick examination on the advancing nature of heavenly mechanics. What's more, the public's advantage in the disregarded corners of room. Tyson's position on P